There we go. Okay, so let's just jump straight in because I feel like we're gonna be here for a little bit of time. This is just to recap what we were doing last week, Tuesday. So now if I have any new people in this class, especially if you have not done functions in school or in class, this may seem scary. Okay, and I don't want you to panic. Remember that all of the lessons are on the Watobe website. You can watch them all over again. You can watch them 7 times if you want to watch them 7 times. But don't panic if you are feeling lost with what's going on with this. The thing that we're going to learn today is going to be a little bit different. Okay, so really this is just for people who are here and sort of know what's going on. Yeah, no, I know if you're feeling nasty, I totally understand that. Okay, and remember you can rewatch the videos when you need to. Okay, let's try and go through this question. I'm going to do a little bit with you and a little bit of it I want you to try by yourselves. But some of what we're going to be talking about is some sort of exam writing strategy if you get a question like this. So let's have a look at this first question. Let's read our instructions first. The graphs of y minus 2x plus 4 equals 0 and g of x, which is equal to ax squared plus q, are shown below. The graphs share a common x and y intercept, and then it tells us to determine a few things. Okay, let's first have a look at this equation over here. I just want us to look at this equation. What about that equation looks funny? It doesn't look like what it normally looks like when we work through things. And how can I change it to be like something that we recognize? Who thinks they can help me with that? So at the moment, our equation is y minus 2x plus 4 equals 0. How can I change that equation so that it looks more like the things that we've learned so far? So far, we've learned that a straight line graph is y equals mx plus c. And we've learned that a parabola is y equals ax squared plus q. So that's what we've learned so far. How could I change this equation, y minus 2x plus 4, so that it looks like one of those? I'm open to all suggestions, or you can give me the answer in the chat if you think you know. Don't be afraid to try. Okay. Good, good. Swap that y and swap the o. Excellent, excellent. Okay. I think I would probably move the others over so that my y would stay positive. Okay. But exactly, I want to move the 2x and I want to move the 4. So if my equation looks like this, y minus 2x plus 4 equals 0, and I'm wanting it to look like that, I want to move those other things to the other side. Okay, so I want to move that 4 over and I want to move that 2x over. So I'd land up with y equals 2x minus 4. So all I've done is that I've moved those two things over the equal sign. And now I have an equation that looks much more like my straight line equation. Okay. All right, so that's our first step. And that's before we even look at any of our questions. That's just to sort of help us because they've given it to us like that so that we make mistakes. And so if we take a moment and we rearrange it for ourselves to see what it should look like, then we're not going to make a mistake later on. Okay, now let's have a look at some of the questions. The first question is to determine the gradient of the straight line. Don't overthink that. Okay, and the second question is the values of a and q in our straight line graph. So let's have a look at A. What is the gradient of our straight line? What is the gradient of our straight line? Yes. Good. Good, good, good. And you see, it's nice and easy now because we can see that that's the 2x, which is our m, which is our gradient. Okay, so our gradient is 2. Now, they had written it like this so that we fell for the trap and make our gradient minus 2. They made that as a trap. And so we are going to make sure we don't fall for a trap like that. Okay. Now, if my straight line graph is y equals 2x minus 4, can anyone tell me what the coordinates of that orange point that I've just drawn on the graph are? What are the coordinates of that orange dot that I've just drawn? What are those coordinates? Good. X is definitely equal to 0. What is my y value? Yes, and for my y value is going to be negative 4. Okay, and we know it's going to be negative 4 because it's the y-intercept of our straight line. Okay, it's our y-intercept of our straight line. Excellent, guys. You're doing so well. I'm so proud of you. Okay. Next thing that I would like us to figure out is I would like us to figure out this green dot over here. First of all, what is that green dot? To sort of like in words, what is that green dot so that it'll make us easier for us to find? Good. It's the x-intercept of what, Emmanuel? So in this case, it's the x-intercept of our parabola and of our straight line. Okay, we don't have enough information in our parabola to figure out what it is, but we definitely have enough information in our straight line to figure it out what it is. Now, if it's our x-intercept, that means that our y value is equal to 0. And so we can make y equal to 0, and we would have 2x minus 4. 4 is equal to 2x, which means x is equal to 2. So these coordinates over here are 2 and 0. Okay. My next question to you is, if that's 2 and 0, what would this dark green point be? And I want you to think about symmetry of a parabola. Symmetry of a parabola, what would be those coordinates? Excellent. Negative 2 and 0. Guys are on a roll. Yes. Good. Good. Okay, guys, just so that you don't panic, Yolanda had load shedding, which is why she's not here anymore. So if you see that glorious face over there, that is Nicole. Nicole is going to be our TA for this lesson. And so if you have any questions or you're needing help, you're welcome to send her a direct message, and she's here to help with whatever you need. Okay.
Hi, great hands.
Cool. There we go. Okay, so we've got our negative 2 and 0, we've got our 2 and 0, and we've got our 0 and negative 4. Cool. Now we're going to have, now that we've done all of that information, when we're nice and calm and we're not stressed, we just thought about things step by step. Now we're going to look at the second question. We're going to look at B. For B, we now want to find the values for A and for Q. Now, one of those is really easy. You should know one of them already. Which one do we know already? Good, Emmanuel. We know Q. Because it's our turning point. It's down there. It's our y-intercept of our parabola. And so our Q value is going to be negative 4. And we know that because we took all of this time to write everything on our diagram as we were working. Okay, so we definitely know that we've got ax squared minus 4. Okay, now I'm still trying to find A. Suggestions. How can I find A? If I know that my equation right now is y equals ax squared minus 4, how can I find the value for A? Don't be scared of giving the wrong answers, guys. Just try. Say what you think. Remember, often the wrong answers help us know where we're going wrong. Good. Okay, so we need a value. So Portia, yeah, we need a value for x and y. And we need another answer there was substitution. Excellent. Excellent. We're going to substitute in value. So Lee Kaylin, we actually need to substitute an x and a y in because we're trying to find out what A is. So we're going to just substitute any other point that we have in here. Great, guys. We're going to substitute a point in. Now you could choose negative 2 and 0 because that's on our parabola. Or you could choose 2 and 0 because that's on our parabola. You can choose whichever one you want. So I'm going to choose 2 and 0. So I'm going to substitute in 2 and 0. Now remember that that is our x value and that is our y value. Okay, so my y value is 0. My x value is 2. So I land up with 0 equals 4a minus 4. I'm going to move that 4 over. So 4 is equal to 4a, which means a is equal to 1, which means that my equation is y equals 1 x squared minus 4. So we have found A and we have found Q. Emmanuel, how can I help?
Hello, ma'am.
Hello.
Ma'am, I wanted to know, why did you use 0 as your substitute for x? I meant for y. Like when you substituted 0 is equals to a bracket 2 squared minus 1. I wanted to know, why did you put a 0 there?
So I substituted in this coordinate over here. So I substituted in 2 and 0. And in that coordinate, my x value was 2 and my y value was 0. So that was why that was 0 and that's why that was 2.
Oh, okay. Thank you, ma'am.
Sure, no problem. Okay. Let's have a look. And remember, guys, ask questions whenever you're needing. That's what we're here for. Just use the hands up emoji if you're needing to ask a question, and then I can unmute you. You could have definitely used simultaneous rules to find A. No, you don't have to have the 1. You can just have it as y equals x squared minus 4. Okay. If we have a look at question C, it says the x-intercepts and the turning point of G. We've already found that. We did all of our hard work already. Our x-intercepts are -2 and 0 and 2 and 0. And our turning point of G is 0, -4. So we did all of that hard work already. We don't have anything else we need to answer there. Now, obviously, if you were in a test, you would need to write that out. So our x-intercepts, we've got -2 and 0, and 2 and 0. And our turning point, we've got 0, -4. Remember, turning point is just where it's either the maximum or the minimum of our parabola. Now, our last question, let's see if anyone remembers anything from Thursday. Our last question is the domain and the range of G. So G is this guy over here. G is our parabola. Okay, so my first question to you is, before you give me anything, let's just do this step by step. What is domain looking for? What is domain looking for? Like, if we had to say, like, when it asks us the domain, if we had to say it in a normal sentence. Yes, Shama, exactly. The domain is, what are my possible x values of this parabola? So can anyone tell me what my possible x values for this parabola are? What are my possible x values? Do I have any limits on what my x values could be? Remember what these arrows mean over here. Okay, so lots of people, exactly. Lots of people coming in with the -2 and the 2. And it's a very normal mistake, because they are our x-intercepts. And so we see the word domain and we think, okay, domain is x, and then we think x-intercepts, and those are our numbers there. But domain is actually saying, what are the possible x values for this graph? What are the possible x values? So, like, for example, x could be -1, x could be 0, x could be -2, x could be 3, x could be -4, x could be 5. Okay, this arrow over here is meaning that x is going all the way to -infinity, and this arrow here is saying that x is going all the way to +infinity, which means that my possible x values for this graph are anywhere from -infinity all the way to +infinity. And another way of writing that, and this will always be the answer for domain of a parabola in grade 10, is that x is an element of any real number. That's all that that means. Basically, this just means x can be any number. That's all that means. It's just a fancy way of writing that x could be any number. Okay. Let's have a look at the second part of this. So the second part is saying the range of G. So now again, I want you to think about what that's saying. That's saying, what are the possible y values of this graph? What are the possible y values of this graph? Temba, I almost love it. I'm so close to loving it. I'm like on the edge of loving that answer? And Paul, I love that answer. I love everything about that answer. Temba, can you try and establish between your answer and Paul what the difference was? So Tiamo, I love your answer the same way that I don't love it fully. I love it in the same way that I love Temba's answer. So I love it a lot. I just don't love it with my whole heart. There we go. Now I love it with my whole heart. Beautiful, guys. Okay, so lots of people want to say that y needs to be greater than -4 because we can see that our minimum value, that's our minimum value for y. Okay, so y has to be greater than -4. So we know y has to be greater than -4. But the thing is, y is also allowed to be -4. And so we also have to have that line that's saying y is allowed to equal -4. And so we can write it like that. Or we could say that my smallest number is -4. And my biggest number is positive infinity. But make sure that that is a square bracket, because that square bracket is telling you that it is also equal. Okay, so we have got our range and our domain written on here. I know that this looks like a lot. So for anyone who's joined late, if this is what you're joining, I can only imagine sheer panic happening in your brain. But remember, this is just going over what we did last week. And so we are going to look at some new things today. So please don't panic. So the small bracket, every time this round bracket means it's not included. That's what that round bracket means. So let me draw some things up here for you to help understand what that means. Basically, if I had y has to be greater than 4, then that would look like that. Okay, so y would be bigger than 4. If I said y is greater or equal to 4, then I would have a square bracket and have my 4 and that. So basically the square bracket and the round bracket is the difference between an open sign and having it included. And for infinity, infinity always has a rounded sign. The sort of least complicated way to explain that is that infinity is not something that you can ever reach, because infinity can always be bigger than the infinity before. And so because we actually can't have the number infinity, we can't include infinity, which means it can't have a square bracket, because we can never reach infinity. And I feel like I've said infinity too many times now. The E is just saying that's what it is. So this is saying y is, so that E is basically like a fancy way of saying is in maths. Y has a minimum of -4 and it goes to a maximum of infinity. Basically, that's what that sentence is saying to you. So the domain of this type of question, and it will always be this answer for a parabola in grade 10, is that in our domain, it's saying what are our possible x values of this parabola. And the thing is, because this arrow is going to carry on going all the way to negative infinity, and this one's going to carry on going all the way to positive infinity, it means I could have any x value between negative infinity and positive infinity. And so that is why I would have these answers. So it's either the top one, or you could write it as the bottom one, whichever one you want. Yes, mathematical language is otherwise. We are very nasty, and they like to make things as complicated as possible, but that is just how we roll. It's how we roll in maths. Okay. Cool. Let's jump into what we're actually going to be jumping on today, which is our new graph, which is called the hyperbola, which is a very, very exciting little graph. Okay. I love the hyperbola. The hyperbola brings in a brand new word for us, which is one of my favorite words in maths. Who thinks they can tell me what my equation of a hyperbola looks like? What does the equation of a hyperbola look like? We know it's going to start with a y. Who has done this in class and can tell me the equation of a hyperbola? So if you don't know the name of what you've done, but you have done things in class, the hyperbola is one that looks something like that. Nice. Yes, guys. Yes. A over x plus q. Excellent. Beautiful. I love it. That is our equation for the hyperbola. So remember, I keep on stressing in grade 10, it's so important that you know the different equations. We need to know that a straight line is y equals mx plus c. A parabola is y equals ax squared plus q. A hyperbola is a of x plus q. These are things we have to keep in our head. Okay, so this is our equation of the hyperbola. Let's try to break this up a little bit. I'm going to move him down so that I can write some things around him. So, who thinks they can tell me what that A does? What does that A do? What does the A do in this equation? Now, obviously, I'm asking this to those of you who've already done this in class. So if you have no idea, that's very normal. Please don't panic. What does this A do in our hyperbola? Yes, good, good. It determines the position of the hyperbola. Like Portia, it determines the shape of the graph. Excellent. So do you start seeing that there's some common things that are coming on? So when we did the parabola, the A determined if it was a happy or sad parabola. And here it's also determining its shape, but more so it's determining its position. But you can also say shape. So you can keep it in the same sort of brainwave as your parabola. Now, if A is positive, then your hyperbola, I'm going to just use a different color. Your hyperbola is going to be in quadrants 1 and quadrants 3. That's if A is positive. If A is negative, then your hyperbola is going to be in quadrants 2 and quadrants 4. Okay. Let's see if we can answer something else now. I can feel the sheer panic sort of coming off some of you at the moment. Please just keep it calm. Don't stress. We've got the whole week on this today. What is that Q telling us in the hyperbola? I'll accept a whole bunch of different answers here. Oh, I love that answer, Paul. Okay. I love it. Does someone have a different answer? Depending on how you would have been taught this in class. You may have been taught something with moving. So the Q is definitely the asymptote. It is your, yes, beautiful, Oweti. That is exactly what I was looking for. It is the shift of the graph where it's going up or it's going down. So basically, if I had this same situation, let's say I had a +1 over here, then this whole graph is going to shift up by 1, and my asymptote is going to be on 1. Now, if you've never heard of the word asymptote before, please don't panic. I would love to know if someone can give me a definition of an asymptote, and then I will tell you, I will give you my best way of thinking of an asymptote. But can anyone tell me what an asymptote is? Yes, lovely. Tell me, what is an asymptote? Tabese, I think I have asked you to unmute. I don't know if it's not coming up on your side. Okay, I'm gonna have to move on to someone else. Shadow, what's an asymptote?
Ma'am, an isotope is a line or curve that acts as
it was a great start. It's a line. I think you may have lost signal. Tiamo, yes, it's an imaginary line where the hyperbola should not go over. Okay, I love that definition. So the thing is, it's not even that it should not go over, it cannot go over. So if we have a line where we have an asymptote, something cannot cross that asymptote. So let's, for example, let's just put our asymptote somewhere like this. Okay. We also see asymptotes when we deal with something called an exponential graph, which is what we're going to do next week. When we have our hyperbola, we actually have two asymptotes. In grade 10, we have this red one that I've just drawn, that red line down there, which is where x is equal to 0. Now, in grade 10, that one is always there. That one doesn't change. It stays the same. So one of your asymptotes will always be x is equal to 0. And the other asymptote is the one that's going to move up and down, and that's going to be dependent on this q value. Okay, so let's say that this was a y equals to -2. Then my q value would be -2 because it is my asymptote. All right. If I was to draw this hyperbola, let's say my a was positive. Basically what's happening is that as I'm trying to get closer and closer to that red line, the red line is pushing back. It's saying, no, you cannot cross me. And so I can get really, 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 really close to it, but I can never, ever, ever, ever touch that red dotted line. And the same thing happens in this top section over here. So as this starts coming around, it gets very, 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 very close to that red line, but it can't ever touch the red line. So it gets close to the asymptote on the y-axis, and it gets close to the asymptote on the x-axis, but it can never touch it. So the same thing happens here. I'm really close to the asymptote. I'm coming down, and I get really, 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 really close, but I can't ever touch it. And so I think of the asymptote as the ultimate friend zone. So I all want you to think of that friend that you have that has feelings for you, that you have securely put into the friend zone. That is what the asymptote is. You can get really, really, really close to that person, but nothing's ever going to happen because they have been friend zoned. And that is what the asymptote is. The asymptote is the ultimate friend zone. When it's never going to happen. You can get really close to it, but it's not going to happen. So think about anyone that you have either friend zoned or who has friend zoned you, and think about the asymptote situation. No, I didn't. Look, I got super close, but I didn't touch it. Super close. It's not touching. That is what the asymptote is. The asymptote is the friend zone. And I promise now you will never, ever forget what the asymptote is, because as soon as you see it, you're going to be like, yo, that's the friend zone, and it's going to make you sad. But now you know, so it's helpful. Okay, let's try and go through this question. Ketwa, how can I help?
Ma'am, why is the x-axis on the line that should be the y-axis, ma'am?
Okay, so are you talking about this x is equal to 0 over here?
Yes, ma'am.
Okay, so it's not saying it's the x-axis, it's saying it's the equation of the asymptote. So at that point, that is when x would be equal to 0. So it's the equation of that asymptote.
Okay, thank you, ma'am.
Okay, and this point over here would be when y is equal to -2. Good, it should feel personal, because when things feel personal, we remember. That is why it's important. Okay, so this is sort of just a vague introduction of the hyperbola. We're going to sort of play around with a couple of them today, and we're going to see if we can figure out what the equations are. And then on Thursday, we're going to try and draw them. Okay, but now we have an idea of what a few things are. So let's have a look at this. I'm going to go through this one with you. So I'm just going to talk you through this one entirely myself, and then I'll give you one to do by yourselves. Okay. So they've told us that the point P is 1 and 4. We can also see on our diagram over here that that point over there is -5, which means that this asymptote's equation is y equals -5. Okay. And the other asymptote, the one that we always have, which is this guy, but it's not going to be drawn in for you in grade 10 because it's on the axis, is x is equal to 0. Those are our two asymptotes. Okay, we always have two asymptotes for the hyperbola. Okay, I'm just sort of trying to put things together. Oh, don't worry, Shadow, I thought that's what happened. Okay. So now from here, we've got to try and break up things a little bit. So we've got y is equal to a over x plus q. It always starts to just write out your equation. Just write it out, get your head straight, know what you're dealing with. Okay, we know that. Now, you already told me something great about q earlier. You told me that Q is your asymptote, okay, but it's your Y asymptote. So it is telling you this number over here. So by seeing that, we know that our Q value is -5. So we can actually substitute that in straight away. And we can put in our -5. Okay, now I want you to think about the very first question we started today and a theme that we've been doing when we've been looking for equations. When we are trying to find a variable, so now I'm trying to find this lonely little a over here. How do I find a variable? How do I find a variable? What can I do to this graph over here? What can I do? Oh, wait, tell me what I can do.
Oh, hi, ma'am. I think we'll have to move. Okay, we'll have to let our y be 0.
Okay, so now the problem with that is that we don't know what our x value would be when our y is 0. And we need to substitute in a whole coordinates. We need the x and the y value.
Oh, yeah.
But it was a good thought. Can you tell me something else I could put in there though? What could I substitute in? Have a look at any point that is lying on that graph.
I'm kind of lost.
That's okay. That's okay. I'm going to get some help from some of the people in this chat over here. Let's go to Sanda. Can you tell me what I'm going to substitute in?
1 and 4.
Good. I'm going to substitute in the point that I have of my graph over here. I'm going to substitute in that 1 and that 4. Okay. So we're going to substitute in whatever point we can find in our graph. That's my x value. That's my y value. So I'm going to make y4. I'm going to make x1, and then I minus 5. Okay. Now, if I have a over 1, oh, I got the minus 5 because my asymptote was y equals -5. And whatever your y asymptote is, that's always going to be your your Q value. Okay. It's always going to be the same one. So now I'm at this point where I've got 4 equals a over 1 minus 5. Do I need to write that 1 that is under the a? Is it necessary? Yes or no? What do you think? Is the 1 necessary? No, because anything divided by 1 is itself. 5 divided by 1 is 5. X divided by 1 is x. A divided by 1 is a. So we can just write a. Okay. And now we're just solving for a. So I'm going to move that 5 over. So I'm going to have 4 plus 5 is equal to a, which means a is equal to 9. And so my equation, give myself a bit more space over here. My equation is going to be y is equal to 9 over x minus 5. And then we can do some checks. We can be like, well, my hyperbola was in quadrants 1 and 3, so the ones like that. And that's telling me that it's positive, and 9 is definitely a positive number. So that's a good sign. Okay. You can double check your asymptote. So look for your friend zone over there. That's y equals -5, and that's -5. So we're solid. And that's our full equation. That's all we have to do. So the first thing we want to do is we want to put in our y asymptote as our Q value, and then we want to substitute in a set of coordinates so that we can find a. Basically, that's what we're doing. Monica, how can I help, sweetheart?
Hello, ma'am. Ma'am, I wanted to ask, how did we get y equals to -5?
So you just have to look on the graph. So they'll always give you an asymptote. So the asymptote will be the dotted line, and then you look at where it's crossing. So it's crossing my y-axis at -5, and so that means that this equation is going to be y equals -5.
Okay, ma'am. Thank you.
Sure. Okay. You ready to try one alone? Let's see if you can try the next one. I feel good feelings. Juliet, how can I help?
Oh, ma'am, I was just asking if you could stay on the page just for 5 seconds.
Sure. Q is y times x Sybil, what is going on in that sentence? I don't know what's happening. Oh, Q is the y-intercept. No. So the the reason that it's not the y-intercept is because in order for it to be the y-intercept, it has to cross the y-axis. And it's never going to cross the y-axis because the y-axis is an asymptote. The y-axis is the friend zone. So it's going to get really close to the friend zone, but it's not ever going to touch it. So we don't have a y-intercept with the hyperbola. You will have a y-intercept with the hyperbola next year, but not in grade 10. I know, Nomsa, I know. But next year you'll have one because next year it shifts everywhere. So in grade 10, it just shifts up and down. But in grade 11, it shifts side to side and up and down. It is still the alphabet. Oh, brain break. Oh my goodness, look at the time. How did that even happen? Okay. Brain break. Is the x asymptote equal to 0? Yes. So in grade 10, it's always going to be x is equal to 0 and then y wherever the y asymptote is. Okay, let's see if anyone can solve this for me today. I had a couple of grade 9s who managed to get there, which I was quite chuffed with. I'm trying to find what the question mark is here. I'm going to let you know that there are two. Oh, don't worry, we definitely will be doing more of those. Don't panic. I will let you know that there are 2 traps that you could possibly fall into with this question. But I am curious to find out what that question mark is. It's not 19, not 31. Not 22. Nomsa! Nomsa, that was so quick. Are you able to explain how you got it? Or where to?
I think our answer is 15.
It's not 15. So a couple of you have gotten the right answer. Nomsa, can you explain how you got to your answer?
Ma'am, I just guessed. Sorry, but I just guessed.
Oh, I'm sad. Oh, okay. If anyone got the answer of 25 and you're able to explain how you got 25, let me know. Who have I got over here? It's not Tando. Can you tell me how to get 25?
Yeah, yes, ma'am.
Okay.
The worms, I divided them by 3, and then I got 7. So
Good.
the second one, I took the 7 and minused it by 19, which I got 12, and divided the 12 by 2, which gave me 6.
Good.
And
Nice.
then what did I do? I took the 6 and the 7, added it together, gave me 13, gave me the answer for the leaf, which was 2.
Good.
And then I took the worm plus the flower, times it by the clock, and I got the
Oh my gosh, you landed up getting it right, but you still fell for one of the traps.
Yeah.
How much does this worm count for?
7.
No
ways, it doesn't have the flower.
It doesn't have a flower. This worm is 5. Nice job though, you did really, really well. You got far. You got very, very far. And then this one, there are actually 2 flowers. So that's actually 4. And then this clock over here is not set on 6, it's set on 5. And so it's 5. So it's 4 times 5, which is 20, and 20 plus 5, which is 25. Very well done to those of you who got there and saw the traps. Nice job. Okay, so close yet so far. Let's jump back into hyperbolas. No, Nomsa, don't give me that emoji with heart and the eyes. You guessed it. Okay. Let's try another one. Okay, let's try this one over here. So what I'm wanting for this one is I'm going to be nice to you in the beginning. Just for this question, I'm only going to be nice to you here. I'm just going to take away this just for this question. I'm going to bring it back in the next one. Okay. So I would like the equation of this graph, and then I would like, no, I'm going to be nice as well. I just would like the equation of this graph. Let's just start there. Okay, just want the equation of this graph. That's all I want. I'm gonna start you out a little bit by saying y equals a over x plus q. I want you to look at the information you've been given, and I would like you to fill in what this equation would be. Beautiful. Q is -4. I love it. I love it. We can see that our asymptote is going through -4. So this asymptote is y equals -4. And this asymptote, which hasn't been drawn for us, is x equals 0. Beautiful. So Q is equal to -4. Excellent start, guys. Excellent start. Now think about what you do now. And Paul, you're welcome to write it in the chat. Avalile, are you going to help us? So there should be a button asking you if you're wanting to unmute, and you can then unmute from there. There we go. Hi.
Ma'am, the
Yeah.
y is it going to be 3?
Okay.
Because
So if that's my x and my y, what am I going to sub into that y?
the 3,
Is it +3 or is it -3?
the -3,
Yeah, so I'm going to sub a -3. Okay, and then what am I going to sub into my x value?
-1.
Good. -4. Okay, cool. What's my next line going to look like?
I forgot now, ma'am. So
That's okay. Don't worry. I'll take it on from here. Thank you for trying.
Okay, ma'am.
Okay, so from here, I'm just going to make my a negative to make my life a little bit easier. So I'm going to say -3 is equal to -a minus 4. Move that 4 over. So -3 plus 4 is equal to -a. So 1 is equal to -a, which means a is equal to -1. So those of you who got the 7, what happened was you didn't change your signs. So either you didn't put in the correct -3, or when you moved your 4 over, you didn't change its sign to a positive and you jumped over. And so we get a is equal to -1, which means my equation for this graph is y is equal to -1 over x minus 4. That is going to be my full equation. How did this go? Please show me with emojis how this question went. Happy, sad, somewhere in between. Okay, I'll try zoom in on the next one so that it's a little bit clearer. Yes, you could have said negative. No, it needed to be -1. We couldn't say -a because we needed to give a value for a. Okay, so the -1 came in by substituting in these points over here. So we substituted in our x value of -1 and our y value of -3, and then we just solved for a. So this whole section over here, this is just solving for a. And this is subbing in -1 and -3. Yawning. Okay. I'll be asking you some questions. All right, let's try another one. And now I'm going to add some things onto this. So I would like the equation of this. So I'd like a few things. The first thing I would like is I'd like the equation. I would like, so the equation of the graph. I would like the equation of the asymptotes. And I would like the domain of this graph. So those are the three things I'm looking for. I'd like the equation of the graph. I would like the equation of the asymptotes, and I would like the domain. By one, okay, hold on, Kevin, let me just have a look at what you previously wrote. Okay, Kevin, I'll pop up there as soon as we finished with this question, I'll pop back up. Okay, I like it. So that's this asymptote here. Shadow, that's okay. Remember, you can always watch these videos on the website. So just be careful, Lunelo, that it's above. It's going through +1. So it's going to be a positive value. So when we're starting with this question, if I'm looking at my first question, so the equation of the graph, I know at the moment I've got y equals a over x plus 1, because my q value will be whatever my asymptote is. Okay. Then I'm going to substitute in, so I'm going to sub in a point that I have on my graph. So I'm going to sub in -5 and 2. 2 is equal to a over -5 plus 1. I'm going to move my a over. 2 minus 1 is equal to a over -5. 1 is equal to a over -5, which means a is equal to -5. So my equation is y equals -5 over x plus 1. Awesome. For any of you who got there, that's great. So that is my answer to this first question. Y is equal to -5 over x plus 1. Moko Kubale, how can I help?
Hello, ma'am.
Hi.
Ma'am, can you please re-explain? I didn't understand there by 2 minus 1 is equals to a over -5. I didn't understand from there.
So all I did over there is I moved this -1 onto the other side, so it became -1. And then I had 2 minus 1, which is just 1. And that's still equal to a over -5. And then for my last step, all I did was, because I'm dividing by -5, I just multiplied it up. So I said 1 times -5, which is -5. And so I got my answer for a.
Okay, thank you, ma'am.
Okay, once we have our equations, so that is the first answer. So that is y equals -5 over x plus 1. My second question to you is, what are the equations of the asymptotes. What are my two equations of my asymptotes? For a hyperbola, there are always two equations. What are my two equations of my asymptotes? One of them is written on the board. Good. Y is equal to 1. What is my other one? The other one is the same in the whole of grade 10. Beautiful. X is equal to 0. Okay, now when they ask you this question in tests and exams, do not forget about this guy. It's easy to forget about him because it's not drawn on the graph in grade 10. So don't forget about it. Okay, so we have y equals 1 and x equals 0. It's this one over here. Let me get a different color because we used purple already. Y equals 1 and x equals 0. That's what these two are. Okay. Now, the domain. Remember, the domain is saying, what are our possible x values of this graph? What are our possible x values of this graph? So let's try and break this down a little bit. This is going to go on forever that way. This is going to go on forever that way. So it's going to go all the way to negative infinity, and it's going to go all the way to positive infinity. Okay. So we can start by saying x can be any real number. But can x be any real number? What are we forgetting about? We're forgetting about something super important. Can x be any real number? Yes, Kutlano, yes. X cannot be the friend zone. X is not allowed to equal 0. Okay, it can't equal the 0 because it can never ever touch the asymptote. And so if it can't touch the asymptote, it can never be equal to where the asymptote is. And so when we have the domain of a hyperbola, we say x is equal to any real number, but x cannot equal 0. And in grade 10, this will always be the answer for the domain of a hyperbola. It will always be the same answer. So always, always, always the same answer in grade 10 for the domain of a hyperbola. X can be any real number, but x cannot be 0. And the reason x can't be 0 is because that is our asymptote when x is 0. Okay. Does anyone have any questions about that? Okay. Oh, yeah. I see. Nani, how can I help?
Hi, ma'am.
Hi.
For the last one, when you shift -5 to 1, so I'm going back to that first thingy, right?
Yeah.
The equation. When you shift -5 to 1, why doesn't it become +5?
So it only becomes +5 if we're adding or subtracting, but we're not, we're timesing. And so when
Okay,
it
thank
times
you.
as it stays the same sign.
Okay, ma'am. Thank you.
Okay. Sable, this is definitely not trig. This is functions. We are going to get into trig graphs after this course, but this is not trig. Sunda, we're going to find range in the next question. And then Kevin, from here, I think this is what you were asking about from the 1. If we have 1 is equal to -a and we're trying to find a, basically I'm just dividing those both by -1. And so 1 divided by -1 is -1, and the -a divided by -1 becomes +a. Or you can just switch them around. So move your a that side and your 1 that side. Whatever works easier in your head. Okay, let's try to do one more question. I know our time is limited, but let's just try this one. Okay, so for this one, I'd like you to do the same thing. Now it should be a bit quicker because you're feeling a bit more comfortable. First thing again I want is the equation of the graph. Second thing I want is my asymptotes. And then the third thing I want now is my range. And now for range, I want you to think carefully. Think about what we did for the domain. Okay. Or where to? Yeah. How can I help?
I would love to do the equation for this one.
Beautiful. Talk me through.
I think we'll use the point 1 is to 9.
We're definitely going to use that point. What do we have to start by putting in first?
Okay, our y will be equals to 9.
Okay, we first just need to write one step over here. So I'm going to have
Okay,
a over x, and then what I'm going to have that plus
plus
over here.
q. Plus q.
But what is q?
Our asymptotes.
Yes. So in this graph, what is that asymptote going to be?
6.
There we go. Okay, so that's our first step. Okay. Talk me through from there.
Then our y will be 9.
Good.
Our x will be 1.
Good. Okay.
Then we'll have to move our 6 to, it'll come this side. Then it
Good.
will become negative 6.
Good.
Then 9 minus 6 is equal to 3. Which will be
Beautiful.
our
So what does our equation look like? Y is equal to?
is equal to a.
What is a?
Y is equal to 3 divided by x plus 6.
Yes, well done. Excellent. Excellent. Nice work. Okay. Canva, are you going to give me the next answer? Have I lost you, Canva? Okay, I'll try and move down the line. Emmanuel, can you give me my next answer?
Ma'am, the next answer is the asymptotes for x and y, and the y asymptote is 6 and the x asymptote is 0.
Beautiful. Thank you. Excellent, excellent, excellent. Okay, I'm needing help now for my last answer, the range of this graph. And I've told you to think about what we did for domain. Lee Kalen, what is my range of this graph?
Ma'am, isn't it y is the element of real numbers? Y
Beautiful.
equals 9. While y can't equal 9. Sorry, ma'am.
So close, so close. Y can't equal?
9.
No. So close though. What's your asymptote?
6.
Yes, there we go. There we go. Okay, nice job, Lee Kalen. That was great. Okay, so again, it could be y is equal to anything, and then it can't be the asymptote. So this one will change depending on your graph, but that's how we would write that. So we've got our equation of our graph. We know how to work out our asymptotes of our hyperbola, and we were able to figure out our domain and range. You've done a huge amount of work tonight, guys. I'm very, very proud of you. And that is the end of our hour because our time just seems to disappear on Tuesdays and Thursdays. But it has been lovely working with you guys, and I will see you all on Thursday, hopefully. There is a poll, if you don't mind putting in your answers for me. Thank you so much. And thank you, Nicole, for putting that poll up for me. Sandasili, you're improving. That's very exciting. Bye, guys. I know time just disappears. I don't know where it goes.